GigaMe Instructor Live Sessions. Today we take a session on system design.
Hello.
Hey, hi. Yeah, so how things going on? Your system design topic.
Yeah, so I just went through a few things.
Mm-hmm.
Caching, course.
Perfect. Let me share my screen. So, did you went through any application system design? I mean, did you try to write the requirements, functional requirements, non-functional requirements?
No.
Okay. So if I tell
Like if
you,
you tell me like which topics I have to go through, like what all is needed,
yeah,
then that will be helpful.
sure.
My
So
background is from .NET, so yeah.
yeah, and there's no issues. Backend technology, whatever, either Node, Java, or .NET. Basically, in system design interview, they will not ask you to write code if you go for
Mm,
high level design, right?
yeah.
In high level, they will just check like how good you are in designing the architecture, technical architecture.
Mm-hmm.
There are two types of role in company. One is called technical architect, one is called system architect.
Mm-hmm.
System architect only focuses on non-functional requirements, and technical architect focus on functional requirement with the development tech stacks.
Mm-hmm.
So it's up to you what you'll choose. If you're good in technology side, you can choose technical architect role. Or if you are good in non-functional, understand the components, understand the system very well, then you can go with system architect or simply architect.
Okay. Right now I'm focusing on development roles.
Okay, yeah. Then what's your experience?
Over 10 years experience.
Okay, 10 years. Maybe then you'll become a lead, I think, right? In,
Yeah. But I'm only applying for senior development roles.
okay. Even in senior development also, they will check you some small portion of the system design around.
Yes, yeah.
So the topic is, limited in system design. These topics are, if I categorize, I already explained you on that day, that first thing, like basic of system high level design is, you know what is system design, then importance of those system design, and then what is non-functional requirement and how to categorize what is functional requirement and non-functional requirement, right?
Mhm.
First is you just need to know what is system design, and what is the importance of this system design, why we should learn this system design. Then third is, whenever you design any application, you should have two types of requirement. One is called functional requirement and one is called non-functional requirement. Do you
Mhm.
understand what is functional or non-functional requirement?
No.
Functional requirement means what? Those requirements which you implement in your application, those are called functional requirement, right?
Mhm.
Non-functional requirements are basically scalability, performance, reusability, flexibility. Those are called basically LITY words are for non-functional. Okay. If
Okay.
I categorize the non-functional,
Mhm.
non-functional requirements are security,
Mhm.
how your system is secure, maintainability, something maintainability. Then you can say like scalability is important, performance, reusability, and reliable. How much your system is reliable. These are comes under the non-functional requirement. Functional requirement simply means of if you give any input, how you expected the output, or basically what are the features you should include in your application. If I
Okay.
take the example of, let's say, if I tell you to design Cura system, you know Cura?
Mhm.
Cura system design. Let's say you need to develop Cura system
Mhm.
application. How will proceed? First, you'll gather the functional requirement. In Query system, if you go for functional requirement, right? Inside the functional requirement in Query system, we have user should be able to post question, right? User should able to post questions in Query website. Then, if user able to post question, user should able to answers also, right? Let's say if you ask some question, I can answer those questions.
Yeah, writing comments. Yeah.
Yeah, these are called functional requirement. Then a user should able to vote and devote those answers. If the answers looks nice and fine, then we can vote it, right?
Yeah.
Users can vote those answers or devote it or something like upvote or devote, downvote, something called. Users should be able to search the questions as well, right? Users should search questions. Means you need to create search bar. Users should able to see the latest feed as well on the notification icon, right? Feed should be able to see feed. So these are called functional. Functional means which makes system proper work, right? If you implement these features, it means your application will work perfectly.
Yeah.
That's why these are categorized in the functional requirement category. Non-functional requirement means like which doesn't need to be implemented, but at good level you have to implement those also, like ability, how much your system is available, how much system is your up and down, consistency. I mean all the servers in your system is consistent or not, giving same input for some output something. Okay. Latency, how you evaluate the latency, how you evaluate the consistency of your application. Those are called non-functional requirements, simply. So generally, in system design, availability and consistency are major two factors for non-functional. Excuse me. So to how to achieve those things? First, if are you, let's say you are a developer, you should able to complete this functionality. A user should able to post questions. If I say I have to implement this feature, user should able to post question. It means I need to create first backend schema of questions schema, right? You need then good knowledge of back database side as well, how to create schema, how to model your DB tables and all. So in DB side also need good knowledge to implement those functional requirement. And after non-functional, let's say we discuss the functional and non-functional requirement, then we have to think like how to achieve the database side. I mean, how your database should be consistent, how your data should be scaled. So on those cases, you need to learn horizontal scaling and vertical scaling in DB side. So please read about this database side scaling.
Yeah, that I know, that
Yeah.
horizontal scaling and vertical scaling.
And let's say you are developing the Monolith application, then please read about why Monolith and why microservices. So did you implement microservices?
No.
Yeah, please read about Monolith application and why microservices, why people are moving to microservices. Once you read this microservices, then in this, see microservices again architecture. Then you have to read about object-oriented design principles also. This is very important, OOPS principle. I think you already know this. This is principles. Then inside the principles, you have to know all the things, like not only theoretically, you have to understand how to implement those pillars in your project or in your application. That's it. Then at database studies, you have to read CAP theorem. You know CAP theorem?
CAP theorem, no. So OOPS principles, you mean like interface, abstraction, polymorphism?
Yeah.
Okay.
That's only. That's only. You
Okay.
have to implement. People know theoretically what is inheritance and all, right?
Yeah.
And though they know a small level of example, class A, class B, extending features taking, no, you have to implement practically some complex example in your let's say Cura system. Inside the Cura system, how you'll implement the inheritance. Hmm? So
Mm-hmm.
those are comes under the OPS principles. In OPS principle, it's a wrong word. It's not a OPS principle. It should be OPS principles and design. So
Mm-hmm.
inside this, you can read about all the design pattern also, all the object-oriented programming paradigm also, then some how to create UML diagram, unified modeling language diagram, then
Mm-hmm.
those use cases. Those are comes under the object-oriented design principles and analysis. These
Mm-hmm.
whole topics are there. Very lengthy topic, but we have to know about in end to end encapsulation, then partitioning, then attributes operations, classes, objects, subsystem layer, message. There are multiple things inside the object-oriented analysis and design principles.
Okay. Yeah.
Multiple, you have to just go through it.
Mm-hmm.
It's a topic inside a topic.
Yeah.
Then, yeah, then cap theorem is important. As a system designer, you should know what is cap theorem, what is CDN. These, please, these are a small topic. Please read it today only. See what is CDN, what is
Mm-hmm.
cap theorem, what is load balancer. Hmm.
Mm-hmm.
Then caching, you already know. I think you read it, right?
Yeah.
Caching.
Caching. Yeah.
Then
Mm-hmm.
API gateway.
Mm-hmm.
API gateway. Then you have to read about message queue, why message queue is important and why should we use this in a project. Then this is simple message queue. Then you have to read about distributed message queue. Hmm? Like Kafka and RabbitMQ are things. Okay.
Mm-hmm.
Then you have to read about communication protocols also. Communication protocol. These are important things. Then wave servers and proxies. If you complete these topics these topics very well, I mean, if you read it from blogs and try to implement some small example, you can easily able to answer all the question in system design round.
Okay. Mm-hmm.
And if you go in more depth level, so in database side, apart from cap theorem, read about some file storage, what is database, why we should use SQL, why you should use no SQL, right? Differences.
Mm-hmm.
Then what is file storage? Earlier days, people used to store file storage, then DB storage came. So read about this in detail. What is file storage? What is DB storage? What is database sharding as well? Hmm.
Mm-hmm.
Database sharding, then database partition. These things should know at high level only, because in companies, the separate teams are there for database, which handle database things, right? That's called DB team. But at a high level, you should know what is
Mm-hmm.
partitioning, how you can improve the performance of DB through indexing, in detail indexing. So that's see, system design also categorize, based on the topic. First topic is just start. What is system design? Why system design? How to go system design architecture? What is SDLC model and system design strategies? Next module came like basics of system design, where you have to read about the functional requirement, non-functional requirement, component of system design. Then system design architecture. What are those architecture? Architecture are monolith architecture, distributed architecture, microservices, event-driven architecture. Then you
Mm-hmm.
have to read about what is object-oriented design principles, right? What is latency and throughput in system design.
Yeah.
Then you can move actual high-level system design. What is high level? What is availability? What is consistency? What is eventual consistency? Then
Mm-hmm.
cap theorem, CDN, load balancer, whatever I have mentioned here. Caching,
Okay.
API gateway, message queue. These all are categorized in this way.
Okay. Mm-hmm.
Then you can read these separate these topics. You can read in database system design, separate module.
Okay.
DB system design. Under this, you can move this topic. Then you have to read at what is scalability, how to achieve the scalability and all.
Mm-hmm.
That's it. At high level, these are the topics which we have to complete to master of system design.
Okay.
And you don't need to write the code in interviews. They will just check how you will able to design the system. And during the system design, you have to write down the functional requirement first. You have to write down non-functional requirement first. Then they'll keep asking question, hey, why you have written these functional requirement? How to achieve this? What are non-functional requirement in your project? How to achieve this? And if you mention I can achieve scalability as a non-functional, then they start. What is scalability? How to achieve scalability? How many types of scalability? Scaling. Got my point?
Yeah. Okay.
How basically interview proceed for system design. Whenever
Yeah.
you start system design interview, you have to draw the components architecture. Then you have to write down the functional requirement, non-functional requirement, and they can keep asking those questions from those which you listed. That's it.
Okay.
So in our portal, we have everything is here. Through example also it's there, everything. Whatever I have mentioned now,
Yeah.
every example is there present. Just go through, read about this event-driven architecture first. What is event-driven architecture? Event-driven architecture we can use in which messaging system, cab booking system, Netflix design architecture, Google architecture, food ordering system, e-commerce design architecture. Event-driven architecture means, let's say you completed one function, right? One functionality, okay? Later some event will trigger which will send the notification to you, like your order has been placed, your order is the way, something.
Okay.
Those are comes under the event driven architecture. If you read about the event driven architecture, just go through it once. Building a real-time messaging system with Kafka and Spring Boot Facebook Messenger. Just see this, what is here. So yeah, first, in the ever-evolving landscape of backend development, the need for scalable, reliable, and responsive system has become paramount as if you see modern applications grows in complexity by user demand. Traditional request response paradigm often struggle to meet this. Currently, if you are a backend developer, you only handling the what? API request response cycle, right?
Yes.
You are making a request to backend server sending data to you, and you are just displaying the data in your UI side. So this traditional request response paradigms often struggle to meet these evolving requirements. So enter Kafka with Spring Boot, a powerful combination that offers a robust solution for handling request and response in backend API service effectively. What is this Kafka? Kafka is here message queue. Okay. In the request response cycle, if you enable the Kafka some message queue, your API services works effectively. It's written here. So what is Kafka? Kafka, originally developed by LinkedIn and later open source through the Apache Software Foundation, revolutionizes the way the link about event streaming and messaging processing. It basically provides a distributed, fault-tolerant, and high scalable platform for real-time data ingestion, processing, and pub-sub messaging system. So when you need real-time data updates, you will choose what? The Kafka or other messaging queue system, right?
Okay. Yeah.
So it's clearly written, just read it. I mean, so what the problem does this approach solve in backend API handling? Earlier, if I don't use, let's say, Kafka or any messaging queue, what was the problem earlier? First problem was scalability. Traditional request response architectures often faces scalability challenges, especially when dealing with a large number of concurrent requests. Kafka's distributed nature allows for horizontal scaling, enabling backend services to handle a massive volume of requests without compromising the performance. That's why it's a scale. You can easily scale the system. They can ask you, hey, you have written the scalability, but how you will achieve the scalability? You can mention, I can include the messaging queue system in between, right? This way you have to
Okay.
answer. Yeah. Now let's say asynchronous communication. By decoupling the procedures and consumers, producers and consumers through Kafka topics, Spring Boot applications can achieve asynchronous communication. This architecture promotes loose coupling between components, making it easier to maintain and evolve the system over time. So you can easily achieve the asynchronous communication between the components. Earlier it was synchronous component. Synchronous means if I make a request to one component, unless I want to get the response, I need to depend on that component, right? I cannot make further API call or whatever. But Using messaging queue, if you implement the Kafka, you can easily achieve the asynchronous communication protocols. Then reliability is also important. Kafka basically ensure the order in which message will be delivered. The order will be delivered. So Kafka ensure message reliability through replication and fault tolerance mechanism coupled with a Spring Boot robust error handling retry mechanism. So what is Kafka? You know how Kafka works?
No, I don't know about Kafka. Yeah.
Any messaging queue did you hear about?
No.
Okay, let me
Okay.
first explain simple process why he messaging queue and why messaging queue is coming in market. So let's say I have user auth service, okay?
Mm.
And here I have, let's say, payment service. Okay, payment service. And here I have, let's say, notification service. All three microservices I have there.
Mm.
User login through system and making a payment, right?
Mm.
So once I make the payment, after payment successful, only notification will be sent, yes or no?
Yes. Mm-hmm.
So means I cannot make the next payment then until
Yeah.
unless if I not receive the notification of first payment, yes?
Yeah. Mm-hmm.
So what is happening behind the scene? Whenever you make a payment here, here we'll write one code for Kafka. We'll integrate the Kafka here. Kafka. Inside the Kafka, we'll create some topics. Topics means send notification topics, let's say. Okay.
Mm-hmm.
When you make a payment, the payment service will send a message to Kafka. Please send notification, something like this. Okay. Let's say
Okay.
hmm,
Mm-hmm.
to Kafka. And this message will wait in Kafka. No issues. Meanwhile, we can process with other payments also. No issues. While making the other payments, whenever the Kafka will become queue is free, he will
Mm-hmm.
get the message, please send notification. Then he will trigger the command to notification service. Notification service will, trigger and send you notification like payment successful. So in this way, everything we are doing here in a pipeline or something like a pipe, queue pipe, a message pipe.
Okay. Mm-hmm.
And this will be in, let's say, for some reason you didn't get, that's why you will feel in some case you are receiving notification later, right?
Mm.
In Google Pay also your transaction successfully happened, but you are
Mm.
receiving notification later sometimes
Yeah.
because those messages are present inside the queue. Whenever a queue is
Mm-hmm.
free, he will, or when the queue will send you a message in same order.
Mm-hmm.
Okay, if something goes wrong, wrong, let's say queue has a special feature to retry, means it will retry and again send you message if something fail.
Mm. Mm-hmm.
Okay, so that's a very powerful feature of Kafka queue. Kafka works in two ways. First one is consumer, second one is producer. Producer basically produce the message which need to deliver in the queue, and consumer is consuming those messages. Clear?
Okay. Yeah.
So in this case, consumer producer is payment service which will trigger notification. Excuse me. Notification service is consumer.
Okay. Mm.
So these are called under the reliability. That's why it's a retry mechanism also there. Now performance. Kafka is high throughput and low latency characteristics. So read this like performance, how to achieve fault tolerance, how to achieve real-time processing, how to achieve. Then in combination of Kafka with Spring Boot, accompanying a solution for handling request and response backend API services. And it's written here, see clearly, what is Kafka and what is the primary function. Kafka is open source event streaming platform developed by LinkedIn and later handed over to Apache server.
Mm-hmm.
Its core Kafka functions as a distributed messaging system or a publish subscribe messaging queue. It enables communication between different components of a distributed system, allowing them to publish and
Mm-hmm.
subscribe to store and process something. So let's say here we
Okay.
have producer group, producer 1, 2, 3. This will push a message. Message will go to this queue, Kafka cluster here. Let's say broker 1. And then consumer will pull those messages one by one.
Mm.
The
So, are
Kafka,
there any other messaging systems, popular messaging systems that?
yeah, we have RabbitMQ.
Okay. Mm-hmm. Because
Same,
we
yeah.
had messaging system in our project, but I never went deep into it because I was
Yeah,
not
yeah,
working
just
that part. So I
okay.
never looked into it, what they did and all that.
No, please look. So that's the things. If you have experience like 10 years, then on free time, look your how project flows completely. What are the files they have used? What library they are using? Okay. If not, you can read the architecture diagram of your project somewhere. It will be documented, right?
Yeah, but I'm currently not working, so I don't have much of
Okay.
that.
Okay.
Yeah.
So these are the components of Kafka. What is cluster, brokers, topics, partition, producers, consumer group. Then Kafka offsets, which will maintain the order of the messages, tracking of the message, retention period, log compaction, and offset communicating. These are the component inside the Kafka. You have to install and download the Kafka library. Like Zookeeper is the one broker for Kafka. You have to install and run the Zookeeper on your servers. So you see here, visit the Apache Kafka website, download the Kafka binary packages, choose appropriate Kafka version based on your system requirements. You can practice it. You can simply create one Spring Boot application or any .NET application, okay? And create one more .NET application, and between these two, try to communicate with the messaging queue Kafka. Okay? Very easy. You just need to do some configuration. See, it's a Zookeeper. You have to start this server, Zookeeper server. Kafka uses Zookeeper to manage and coordinate the brokers. Start Zookeeper if you haven't already. You can use Zookeeper bundle with Kafka for development purpose. Yes, I have used this actually in my system. Then you have to create the topics. Which topics need to be send the messages, produce and consumer message, something. Then it will send the message, and consumer will start receiving the message. So now people nowadays using a lot this messaging system in between the applications. Here it's a code through Spring Boot. You don't need to write code in interview. You just need to see here, interviewer. Good morning. Thank you for coming today. Would like to start off by discussing your experience with Kafka and Spring Boot. Could you tell me about your familiarity with this technology? They will not ask you to write code. See this just relax how much you know. Okay. Yeah, I have extensive experience working with both Kafka and Spring Boot. Kafka is distributed streaming platform that I have used for building real-time data pipelines and event-driven architectures. Provide high throughput, fault tolerance, and scalability, making it ideal for handling large volume of data in real-time scenarios. Spring Boot, one of the other hand, is powerful framework for building Java-based application quickly and this minimal configuration. I have used Spring Boot extensively for developing microservices RESTful APIs using Kafka and all. That's it. Something they will ask you what is the topics and components of Kafka and all. They will not ask you to write code, so don't worry. Similar, go for event-driven architecture. Inside the event-driven, read about messaging queue, cab booking system, Netflix, how Netflix design, Google architecture, any food ordering app, how e-commerce architecture also design. Okay. We have beautiful portals here. Now go to microservice architecture tab and read about what is microservices. First, what is microservices? Using microservices, you can easily see. Here we have exploring the monolithic versus microservice architecture. Okay. So in software architecture, the debate between monolith and microservices approaches has been ongoing. Monolith architecture are traditional architecture where all components of an application are tightly integrated into a single code base. While microservices give you power, like you can create or decompose those applications into smaller, independently and deployed services. Okay. Let's say you have one application, food ordering app. If I design food ordering app as a monolith, everything I will place in single folder, single code base. Okay, like food menu, something, order, payment, message, everything, chat, service, supports, everything I'll put in single code base. But at a disadvantage of monolith is, let's say if I make change in one component, I need to redeploy whole components. Yes or no?
Yeah.
This is the main drawbacks. So you cannot make things scalable because all are in single unit, and it's very tough to maintain. And let's say you know the .NET, and I have requirement in Python technology, but you know .NET, so it means I can't proceed with you, right? Because you know .NET only.
Yeah.
So that component should be designed in same language or same technology stack. This is the very, I mean, disadvantage things. Teams, code base among teams are very. See, technology diversity. Monolith application often use single technology stack, limiting flexibility in choosing the between best tools and technology. Now people use microservice architecture. Microservice architecture addresses these challenges by breaking the application into smaller, and each smaller is a independent application. Okay, like notification is separate application, food order is separate application, chat service separate application, support is separate application, and independent application can be developed in any technology. So if you good in .NET, I will tell you my team, I'll tell my team to, hey, develop this application in .NET. If you are good in Python, I will tell some team member, hey, please develop this portion in Python language. Okay, so it's a technology diversity here. So microservices are easily scalable. Microservices allow for fine-grained scalability where only the parts of the application that requires more resources can be scaled independently. This leads to more efficient resource utilization and cost saving. Now, next is modularity. With services decoupled from each other, changes to one service do not affect others, making the code base easier to maintain and update. It's very easy, right?
Yeah.
Developer can only focus on specific services without thinking or needing to understand the entire application. You don't need to worry about what other application is about.
Yeah.
And deployment flexibility as well. Microservices can be deployed independently, allowing for faster and more frequent updates. This enables organization to adopt continuous integration and continuous deployment process practices, leading to faster time to market and improve agility model quickly. Technology already explain you. Each microservice can use most appropriate technology stack it for specific requirements. This allow organization to leverage the best tools and technology for each service. Now, here exploring the architecture and advantage of Spring Boot microservice. Here are all the keys, principles, and guiding for you to how to achieve the microservices. First, you have to decompose. Then you have to write service autonomy principles. Then resilience, API first design, containerization means Docker you have to introduce, orchestration you have to achieve. Things are little complex in way you achieve the microservice, but it's very, very beneficial. So here is the high level architecture. Let's say we have user service, product service, order service, notification service, gateway service. All five are microservices. User service will only handle the user registration, profile management, authentication. Clear?
Okay.
Product service will only handle the product catalog, inventory management, and product related operations. Order service will only related to order management, processing orders, handling payments. Notification services are only send notifications, email, SMS, whatever. Gateway service here will act as an API gateway. So see, in microservices architecture, one topic is very important, API gateway. You have to read about this API gateway topic.
Okay.
Because let's say we have five services, it means we have five different block, right? So we need something at common place, so which will send the request to those fives.
Okay.
So
Yeah.
API gateway is the here entry gate for us. From external client or from front-end application, we'll hit a request to API gateway. From API gateway, it will redirect to the appropriate service. If I let's say requesting for user service, API gateway will decide how to go to user service. Okay. So in
Yeah.
microservice world, you need to good understanding of API gateway. What is API gateway? How API gateway routes works? How API gateway can transform the request data and response data? You can easily see this. If I open the Zomato application in desktop, okay, and if I open Zomato application in mobile app, you will get different response in both. Just try to observe once, okay?
Okay.
Open Zomato application in desktop and open Zomato in mobile app. You will get different response because this is the API gateway job. Based on the client, it can decide or it can transform the response data.
Okay.
Then we have dependency injection. Yes, Springs, if you use Spring Boot, means you are using dependency injection a lot because everything is configured by Spring Boot itself. Like bean configuration, injection type, inversion control, all things are there. Then you should know AOP. Aspect-oriented programming. What is AOP? AOP can be used to implement cross-cutting concerns such as logging, security, transaction management. For example, logging can be applied across services to log methods. So AOP basically it's a programming paradigm that enables modularization of cross-cutting concerns such as logging, security, and transaction management. These all are available inside the Spring Boot.
So these are all Spring Boot features, right?
Same in .NET also. If you go for
Mm.
.NET AOP, aspects injector, see this?
Mm.
Just read these things here.
Okay. Mhm.
Everything. If you try implement, you can easily get everything here.
Mhm.
Basically, yes, see, logging things, security you can achieve through AOP programming. It's a paradigm. So, see, you get a logger instance, and this logger instance will log the message on different time zone and all. See this. Same thing here also. Logger.log information, date time methods, and it started.
Mm.
This helps to easily trace your error in back inside through login service.
Okay, I'll go through all this. Yeah.
Yeah, then we have Spring Boot, auto configuration, services, starters, endpoint, security, authentication, authorization, role-based access control, expression-based. Then we have protection under the security like CSRF protection, session management, customization. These are things you have to achieve when you create the microservices.
Mhm.
So what I'll suggest you, and yeah, inside the service micro, these are the topics in Spring side: Spring Boot framework, cloud registry, console, API gateway, difficult load balancer, see, heavy breaker, distributed tracing, message brokers, containerization, container orchestration. If you read these things,
Mhm.
if you able to read and understand these topics, means you are become a master of microservices.
Okay. Mhm.
These are so much important and so nicely. I will send you one link. You can
Mhm.
read that author book. Let me send you this link. Yeah, Chris Richards. Chris Richardson. See this. Is site, na? Where are you?
Mhm.
Go through this site, read it in detail. This person makes Microsoft so simpler. Okay, so go through it. I will suggest
Yeah.
you first read the microservice architecture, and
Mhm.
if you complete the microservices, you will know the API gateway behavior, you will know the
Mhm.
load balancer, you will know the circuit breaker, how circuit breaker works, and message broker. These are very important in
Mhm.
microservice world. These topics I already
Okay.
mentioned you.
Mhm.
And then the order which I written here. If you go like this also, if you want to know a little bit what is CDN, read about CDN. What is load
Mhm.
balancer, caching, API gateway, message queue, respective message queue, and all. No, just try to read about how to design in this GigaMe site. Everything is there. How to design any application as well. So advanced caching technique, how to achieve backend caching. Caching क्या होता है? REST API design principles. Like
Mhm.
what is API gateway, what is REST API design principle, HTTP protocols. Okay, then you can read about database architecture design here. You can read about data security, how to access. Then authentication mechanism you can read. Web application architecture. Better to first complete microservices today.
Yeah. Mhm.
Today's make a notes, go and read about microservices and read these topics through .NET.
Mhm.
Okay, next session, please, I will ask you some questions from how to use load balancers, circuit breaker. I mean, you have to explain me what is microservices, what are the things inside microservices.
Mhm.
Okay, so take a targets, create, I mean, go and read about
So
micro.
tomorrow is the next session, right? Yeah.
Okay, yeah, tomorrow. So
But
by
yeah.
tomorrow, you just need to read about what is microservices, okay,
Mhm.
and how to achieve microservices pattern, advantage, disadvantage, and what is service registry, what is API gate. Only two things.
Mhm.
Let me know two things only tomorrow.
Mhm.
and I will
I'll
tell
try because I'll get time only weekends. So yeah, I'll try how much I can do today.
Okay, then schedule it on Monday then, next session.
Okay. Mhm.
Okay, then let's meet on next class, okay?
Yeah, okay.
Sure. Thank you.
Okay, thank you.
Thanks for watching. Want to stay updated and learn more? Follow us on social media.